Afternoon, everybody. Thank you for joining us today. I hope you've got some nice weather where you are. As you may be able to hear, the webinar gods have kindly given me a slightly sore throat today, but that's fine because I'm joined by two of the very best, Sam Black and James Paley. Chaps, how are we doing today?
Living the dream.
Definitely. Everybody's happy.
Excellent. So today we'll be giving you an introduction to the VARA CDS, which is a collaboration between ForSecure and Oakdoor, who are part of PA Consulting. Sam Black is Technical Director at ForSecure, and James Paley is Chief Technology Officer at Oakdoor. I will now hand over to Sam Black, who will take you through today's presentation. The presentation will be recorded and shared afterwards, along with the slides. There is also an opportunity to ask questions throughout the presentation, and we'll answer as many of these as possible at the end. If we don't have time to answer your question on the webinar, we will, of course, follow up with you directly to answer that question. So without further ado, Sam, we're in your capable hands.
Thank you very much, James. And thank you, everyone, for joining. I think just to kick things off, we'll give a little bit of a whistle-stop tour of who ForSecure are, who Oakdoor are, and then we'll talk more about the partnership, what we've built together, what that's composed of, and what you can ultimately do with it. So just a little bit of history of ForSecure. We were founded in 2003 as an information assurance consultancy primarily. And since 2012, we've really become an SME in cross-domain solutions, data diodes, secure information exchange architectures. Today, we are a cross-domain solutions provider and a software house, and we provide software to orchestrate and filter and secure data. Today, we're more than just a consultancy. We are that trusted partner. We work with other UK SMEs, other UK organizations to build and integrate capability and deploy solutions, not just here in the UK, but globally for defense, for government, and for critical national infrastructure as well. But I'll hand over to James to give a bit of an overview of Oakdoor.
Thank you, Sam. So Oakdoor is part of PA Consulting. Oakdoor was founded in around 2015. It's a unique or novel collaboration with the UK government where we built a low-cost hardware-enforced data diode. And now we have built a product business around that technology and are aiming to sell it back into the UK and Five Eyes and beyond to help secure those nations. We try and solve operational commercial needs of both government and commercial clients and customers operating across defense and security, critical national infrastructure, and other areas that are in need for data diode and CDS technology. Sam?
Cool. So what have we done together? We've really taken these two separate, not necessarily separate, these two related paradigms and put them together under one product we refer to as VARA. We have that Oakdoor, the hardware enforced security layer, the unidirectional flow control component at the core of the solution. And James will talk shortly about all of the additional functions that brings with it. And then on top of that, we have an open and extensible software layer really designed to integrate some of the sort of granular filtering of data, but also protocol handling and third-party tool sets that we also overlay, not just from UK partners, but open source tooling as well. So together, what we get is this product that brings these specialisms together under one product name, VARA, and really makes deploying these solutions at scale a much easier exercise. Much less engineering, much less sort of bespoke technical services required in order to put these capabilities into your systems. James, if you want to give an overview of the hardware.
So yeah, the Oakdoor data diode at the heart of VARA is a hardware data diode. it's also a hybrid approach to data diodes. So whereas previously data diodes were often formed with an optical transmitter and a receiver and an optical fiber, the Oakdoor data diode technology is baked into the electronics, into the PCB circuitry within the box. This means that it is not reversible. So it is a true one-way data diode. There is no way to load on the wrong configuration or the wrong firmware and reverse that data flow. And with the provenance that's gone into the secure supply chain, the secure manufacture of the devices, the design, everything means that you have a highly assured one-way data diode, which is critical for those applications where the risk of things going wrong is extreme. So the data diodes also have FPGA functionality that can add additional security enforcing features such as filtering or release control, which are often used when you want to operate the diodes in either an import or export direction. The diodes themselves are a component of a CDS. So you take a diode isn't just what you need in an environment. You need something that solves a business problem, which is where the For Secure collaboration comes in, to take what we have and build a platform for solving a business problem. I also highlight that the diodes are assured by the UK NCSC, USA, the NCDSMO, and NATO as well. There are few varieties of the devices, but they are inherently 1 gigabit per second network devices with very simple operation. Data goes in, data comes out. And I've got an example of the product here, which is at the heart of the VARA device, and with the lid off here so you can see the electronics within. Over to you, Sam.
Cool. So VARA really is the entire integration and ecosystem that we've built around this Oakdoor product. It takes the SDK that Oakdoor bring to the table, and it wraps that in some functionality that makes it very, very quick and very, very easy to deploy that core functionality into your systems. On top of this, we overlay TrustedFilter. TrustedFilter is For Secure's software product to perform transformation and verification of data. It's the core filtering engine when it comes to deploying across the main solution with VARA. TrustedFilter has a lot of different interface standards, a lot of different interface capability, and it prepares data in such a way that it can move over the VARA, move over the Oakdoor data diode, and then be validated as well according to a schema. In addition, the architecture of the solution is such that we can integrate third-party capability onto the VARA platform itself, and all of the software is containerized to enable that composability and allow an end user to compose a solution using all of the components that come with the VARA product. What does this actually mean? So there's a lot of different outcomes of being able to deploy a solution that is, for all intents and purposes, turnkey. You can take a VARA and you can enable a lot of different capability without going and purchasing a bunch of add-on software or services or other capability. So some outcomes here: OT to cloud connectivity. So using what comes natively in VARA, we can enable things like cloud analytics platforms to receive data from an OT network for predictive maintenance, to ensure engineers can optimize and take that output out of the OT environment, but ensure no cloud originating traffic can reach back into that environment. Sensor data, a very important requirement, especially on the OT space, but also in a defense context, is taking environmental telemetry information from assets and aggregating that into wider systems. That could be to defend the asset from external attack, but also to defend that wider system where you don't want that to be negatively influenced from anything upstream. Coalition and third-party data exchange, the requirement to share real-time tracking data with partners, with allies, and having that information sharing policy enforced, knowing exactly which data can move over a trust boundary to a partner, preventing in many cases that path of moving data to the partner of being a path of attack. As well as the sort of more traditional use cases for data diodes themselves, that sort of air gap network bridging, where you have a requirement to move data in one direction. VARA is a product that will enable you to do that quickly and easily. Monitoring, logging, a huge use case for a product like VARA that we'll talk about in more detail shortly. And ultimately, command and control, where you have a requirement to have very, very granular and defined bidirectional movements of data from a system to another system. This could be in a defense context. It could also be in a commercial context for control of assets in a manufacturing environment or an OT environment. There are a lot of different vignettes within which command and control can be enabled with the VARA product. As to patterns for how VARA actually enables this, James, did you want to give a little bit of an overview just of some of the patterns and how they're enabled and reinforced by the hardware?
Sure. UK NCSC publish a bunch of guidance on cross-domain and patterns for importing and exporting data. They are currently being updated, but the principles generally are sound. For example, on data import, the idea here is you need to get data from possibly untrusted, even malicious sources into your secure environment where you need a lot of trust. So the NCSC safely importing data pattern specifies a mechanism in which to achieve that, which is essentially about taking data, transforming it, pushing it through one-way data diodes, verification of the data in multiple ways, ultimately ensuring that data is safe before passing it on to its high side or its trusted location. Data export and the NCSC safely exporting data pattern is about getting the data out from your trusted environment to somewhere less trusted without the secrets going along with it. And that's all about extracting any metadata or hidden information. It can involve signing and release control to ensure only authorized content is exported. And then you've got bidirectional patterns which put together import data flows and export data flows in very in a very controlled way. The Oakdoor data diodes themselves, in their additional FPGA functionality, can load on load sets for this type of operation. For example, the safely importing data pattern, we have an import diode which is all about syntax verification. So ensuring that what comes out of the other side of the data diode is in a very specific data format, which is super important to ensure that the subsequent software is able to trust that information without falling over or being attacked, dramatically reducing the attack surface on that software. In the export direction, we have a load set that ensures only signed content can get over the data diode. Therefore, any information you want to release or you want to export must be appropriately signed. And then the diode acts as that final check on the information before it's released to the lower classification or the lower side of the zone. Bidirectional, again, combinations of import and export diodes, which can form two-way protocols, for example. Thanks, Sam.
Yeah, and I think the key here, and I think you hammered home on it there, James, is that, you know, all of these different components of VARA, from TrustedFilter to the capability James was talking about and the diode there, reinforce each other and defend each other, or defend the next parser from attack, essentially. So where we have the syntax verification within the diode, that hardware is preparing the data in such a way that TrustedFilter can safely ingest that content, can then perform the semantic verification, the policy-based verification to ensure the meaning, the context of that data is correct within the context of the system. Similarly, the software function of TrustedFilter preparing that data on the source side of the system by terminating sort of common and complex protocols and preparing them in such a way that the Oakdoor diode can properly verify their syntax, properly verify their structure. There is a function as well, James, if I'm correct. I can't remember the name of it off the top of my head, where the Oakdoor diode will securely and safely wrap that data as well. Is that correct?
Yeah, so you've got to deal with the case in what happens if the information doesn't pass the checks within the diode. And the approach we take is to wrap that data, to scramble it. So if this was malware being pushed through the diode, that the malware would get scrambled such that it appears inert, or it is inert, and then you can decide what to do with it on the more trusted side. For example, you may choose to simply delete it. It's unexpected data. I don't want to handle it. I don't want to worry about it. I'm going to delete it. Other approaches are to move it into some kind of detonation chamber and maybe do some proper malware analysis or antivirus scanning on it. There are many ways of approaching the data, but the point is the data has been rendered inert, so is unable to be easily executed or automatically executed, or anything that could compromise something on the more trusted side.
Yeah, and I think from our perspective, one of the great things about that was that the data it's easy to identify when that process has taken place. There is a very clear structure of the data when that has taken place, which means you can control and orchestrate ultimately what happens with that data, move it to a sandbox to detonate it, or do some sort of instant response process to identify what's gone wrong, where and why. And I guess just to hammer home on that layered security approach is the ability to integrate third-party components just further enables us to take these core key security enforcement functions and bring new capability into the solution quickly. You know, we've both worked with other partners, for example, such as Glasswall, that is a great product that we can integrate really quickly with this solution. But fun bit, some use cases. So a big thing for Secure and Oakdoor has been cloud integration with VARA. So where we have the requirement to take information from a public cloud environment, structured data, semi-structured data, unstructured data, prepare that data in such a way that we can consume it in VARA and move it over the syntax verifying diode from that data arrived on our side. What that allows us to do is validate that data, ensure that it hasn't been tampered with in the cloud, that it's correct for the use case that we're performing, and then move that on ultimately to the destination system with some assurance that it's exactly what we expect in our environment. And this is a great example of what you would call an import use case, where we need to validate the structure and the meaning of that data. And the layered security approach that we take to this is to do all of those different phases on the VARA product itself. So this is one box handling all of that capability, but with lots of different components orchestrated and composed in such a way to offer the security enforcement functions required to bring that data in safely.
I think one thing that's really cool and that's really exciting me about VARA is, previously CDS systems that they can be complex and difficult to integrate. VARA takes the opposite approach and gives you a box that solves the problem easily in one box with some really high assurable mechanisms for achieving safe import of data from the cloud or OT to IT. That's what I think is a step change in what we've seen previously.
The configurability, the composability, you don't need a team of people to get VARA in and working. You need an engineer in a day, right? To get everything configured, to get your data moving over the diode, to get the verification up and running. It's no longer a laborious exercise. Obviously, there can be complications. There's complicated data types. There's complicated data verification. But generally speaking, the high-level architecture of cross-domain can be implemented with this solution, and any bolt-ons required can run on the solution as well, which is really, really powerful. Really, really cool example of where VARA has a lot of utility is in maritime C2, where there is a requirement for potentially combat systems, could also be commercial systems as well, that need to control a broad set of autonomous or semi-autonomous vehicles. And that really is a great example, as James was talking about, of one of those import and export use cases where we have to export where mission planning, payload commands, potentially some sort of kinematics and kinematic picture sharing. So what the platform knows is going on wider down to an asset. In addition to that, having autonomous or semi-autonomous assets able to feed back into a tactical picture, into a common operating picture, and enable that secure import of data. So that could be things like cursor on target with location information and payload information within. That could be digital motion imagery, so real-time video, for example, or some form of structured imagery to bring into that system. And with VARA, it would be separate pipelines, all configurable using the same product. And that really is one of the primary benefits and powerful use cases of VARA is it's not a bunch of different products that you have to wrangle together to build a solution. The same hardware, the same software, the same operating system, the same orchestration layer can be used to deploy your more trusted to less trusted data transfers and your less trusted to more trusted data transfers as well. Finally, a fun and easy one, and a big use case for solutions like VARA is security operations centers, or SOCs, where you have very broad and almost a sprawl of different protocols and different ways of ingesting logging information. The configurability of TrustedFilter, as well as the ability to have sort of glue code to take information into a format that TrustedFilter can process, allows you to ingest all of these different logging formats. So Splunk, sort of various APIs, syslog, SNMP, logarithm agents, file beats. The list goes on and on and on. I could fill the left half of this slide with 50 logos of different information types that VARA can support with limited, very limited technical services and support capability, support requirements. And the capability is extensible such that as new data types need to be brought in, components can be added to the solution securely via software containers. So we can take, according to a pattern, some software, containerize it in a secure way, and load it onto the system where required to do that initial preparation of the data for TrustedFilter and ultimately the Oakdoor diode, and move that data. That's it for use cases and a general overview of VARA. James, did we have any questions that are coming in from?
Yeah, we've had a few questions. Firstly, thank you, Sam. Thank you, James, for the overview. I'm sure I speak for everybody when I say that's greatly appreciated. We've had a few questions come in across the session. A couple of these I think you've touched upon already. We good just to go back and reconfirm those answers, though. So the first question I've got here is, can I add my own software to VARA?
Simple answer is yes. The longer answer would be, well, there's a few patterns that we will use and do use to add third-party components to the product. Compute is a consideration, of course. If it's some form of super heavy AI agent or something like that, it may not be the best platform for that. However, we are looking at additional compute platforms for the VARA architecture in partnership with Oakdoor. But the answer is yes, and that would be in the form of a secure container image that we would assist with.
Lovely, thank you. Another question here that's come in, and just so everybody knows, there is still a couple of minutes to ask questions if you want. We can always cover them in the follow-up too. Has VARA already been deployed in the UK as a sovereign solution?
Yes. So VARA has been deployed in the UK as a sovereign solution. So the partnership with Oakdoor from ForSecure and ForSecure started last year. So VARA has been a product since late last year, and we have dozens of deployments in the UK already.
Perfect, thank you. And then within those deployments, how easy is it to add new protocol or data type support?
Generally, it's quite easy from a ForSecure TrustedFilter perspective. So TrustedFilter has a lot of capability, protocol handling capability built into it. And there are quite a few different standardized interfaces for information exchange between a flanking application and TrustedFilter. So if data can be prepared in such a way that it supports one of those myriad interfaces, quite frankly, there's probably too many to rattle off on this webinar, then it's a very trivial task. There can be some complexities with complex protocols, but that's where the beauty of the architecture comes in that we can add that third-party capability that will could potentially make that protocol handling easier.
Lovely. Another question here is highlighting that the NCSC last week have started to drip feed some of their new cross-domain guidance. Sam, you mentioned there obviously that VARA has been around since the end of last year, and that guidance, although not fully fleshed out, is still coming. Is VARA set up to support users in achieving that guidance?
Absolutely. Yeah, from my perspective, and I don't know if you want to weigh in on this, James, the new guidance really reinforces an approach that ForSecure has long taken, that, cross-domain is an architecture. There isn't a magic bullet for every situation, but working together with Oakdoor, with other partners, with some of the third-party capability as well, it allows us to deploy that architecture, and VARA is a platform upon which we can deploy that cross-domain architecture.
Yeah, definitely. And things like the importing data or that they talk about in new guidance is all about protecting the next item in the list that's going to be analyzing the data, and that's exactly what the diode does, together with the additional software that ForSecure are providing around the diode.
Yeah, and I
treat
think
the data, inspect it at different levels, protect the next element in the chain.
Yeah, and it's all about. I think the key is, because these are all components, right? We're talking about a diode component, a filtering component, a protocol handling component, and you can reason about and you can appraise each of these components individually. That whether it's the assurance or the functionality of that component, it can be reasoned about. It can be appraised individually as well as part of the solution that you're deploying with the product.
Perfect. Gentlemen, that's time. I just want to say again, thank you very much, both of you, for your time, insight and expertise today. There were some other questions that we haven't had time to cover, but we'll follow up and answer those via email. The recording will be shared and distributed along with the slides over the next couple of days. But for now, let me conclude by saying thank you, everybody, for attending, and we look forward to speaking to you again soon.
Thank you, everyone. Thanks, James and Sam.
Thanks, James. And thanks, James.